Let's look at another example. Now this time the probabilities are given and then we have to construct a table. So previously in this example we had the number of observations in each of those categories was given. So now a survey showed 8% of internet users age 18 and older report keeping a blog. Okay, so 8%. All right. So referring to the 18 to 29 age group as young adults, the survey showed that for bloggers 54% are young adults and for non-bloggers so 24%. These are conditional probabilities, right? So a survey showed 8% of the internet users age 18 and older keeping a blog. So let's define some events. So here there are two things going on, whether a person is young adult or not. So like 18 and older is divided into two groups, 18 to 29 and those over 29. Okay, so that's one thing going on there. And the other is whether the person keeps a blog or not. So we'll define the first event as keeping a blog. So event A is keeping a blog. Now event B is young adult. Okay. So what are these probabilities then? So this first one is 8% of internet users age 18 and older. So that's kind of throwing you off, I guess, because 18 and older is the entire population. Because that population is divided into 18 to 29, then 29 to 30 and above. Okay. People under 18 are not counted. So the 8% here is for the entire population, young adults as well as older adults. So that would be just probability of A. So probability of A is 8%. Okay, you can type 8%. Excel will automatically convert that to 0.08 in the cell, but display it as 8%. Now the next statement is 54%, and what is that 54%? Referring to the 18 to 29 as the young adult, the survey showed for bloggers 54%, or so for bloggers. You're now looking at bloggers. For bloggers 54% are young adults. So bloggers is given. So A is given. So 54% given A, 54% are young adults. So we are talking about probability of B given A is 54%. Okay, and what is this 24%? 24% is for non-bloggers. Now non-bloggers is given. So we're now looking at previously we looked at the population was divided into bloggers, and within the bloggers what percentage were young adults. Now we are looking at the non-bloggers. So given non-bloggers 24% are young adults. So that means this probability is probability of B given not A. A is bloggers, right? Not bloggers will be not A. Probability of B given not A, and that is 24%. Okay. Now the question is, what is the probability that an internet user keeps a blog and is a young adult? So when you see that and, then you know that this is an intersection. So probability of an internet user keeps a blog, so that is keeping a blog is even A, young adult is B. So what we want here is probability of A and B intersection, and that is probability of B given A times probability of A. So that will be probability of B given A times probability of A will give you the probability of the intersection. So let's put a couple of decimal places there. Okay. Now what is the probability that an internet user is a young adult? All right, so let's set up a table like this then it will be easier for us to answer any kind of question that will be related to this problem. So probability of A, okay, so these are called marginal probabilities. When you look at just an event, that's called marginal probability. So probability, because you write it in the margin, I guess. So that would be 8% probability of A. So which means probability of not A, so this has to be 100%, right? The total has to be 100%. So this will be 100% minus that. So that will be 92%. Okay. Now probability of A and B, we just computed that, right? So that this will be intersection. What's going inside is intersection. So that's that. So therefore, that would be the difference, that minus this, because these two should add up to the marginal probability. All right. So now let's find this probability here, probability of B and not A. So we had A and B. Okay, let's do not A and B. Okay, so not A and B will be probability of B given not A, okay, times probability of not A, right? So this will be probability of B given not A times probability of not A. So that will give us the intersection. So probability of B given not A is there, times probability of not A, we have it right here. Or you can do 1 minus that 8%. So that would be our, okay, let's put a couple of decimal places there. So that's the intersection of B and not A. So that's that. So which means this one is the sum of those two probabilities. Okay, so now this is going to be 100% minus that. So this will be that minus that. Okay, so let's put 2 decimal places everywhere. So now with this we should now be able to answer the rest of the questions. Okay, what is the probability that a young adult is a blogger? Okay, what is the probability that a young adult is a blogger? So the young adult is given. So young adult is a given. So what is the probability of A given B? Okay, so that would be, so A given B, so given B, so this is given. So A and B, that divided by probability of B. So probability of B here is what? Probability of B is that. So probability of B is that. So probability of A and B, okay, divided by probability of B. So that will give us the probability of A given B. So what is the probability that a randomly selected individual is either a young adult or someone who is a blogger? So this is union. So either or. So it would be A union B, or A or B. So that will be the addition rule. So probability of A plus probability of B minus the intersection. So probability of A is there. Probability of B is from here. And probability of A and B is there. So now we can apply the addition rule. Probability of A or B is probability of A plus probability of B minus probability of A and B.